I still running the motor with the amp meter showing about 2 amps. The yellow wire is now unhooked. The blue wire is going to my other ground rod, which is only in the ground about 4 feet. The yellow one's actually about 6 or so feet. I pounded in a little bit more. Got a few more amps out of it. Anyway, 75 volts. So now what we see is with this rod, it's like 1 volt less, so it's really not that much better of a ground. But these two rods are approximately 4 or 5 feet apart and at varying depths. So now when I hook up both of them together and touch it to this wire here, voltage jumps another 6 to 8 volts, 8 volts probably, just by having these two separate ground rods connected straight together to these wires going to the ground side of the hairpin here. So I'm going to hook those up. Doesn't tingle you as long as the wire is hooked up. So now they're both hooked up, and I get a little bit more voltage. So I'm assuming that this does seem to be amperage driven. I think basically what we have here is I had another capacitor there just to see if it would help, but it made 0 difference. So ignore that guy on the right there. This is a 60 hertz resonant tank, and we're not even using the secondary side of this MOT. I'm really just using it as a choke or a coil just to pair with this dual hairpin thing here. So obviously the more inductive resistance we have, or the inductive reactance we have, or the more resistance as in a incandescent bulb filament, the more the voltage goes down, the lower the voltage. Let me see, and if you notice, I didn't show you before, but when I hooked up that yellow wire, the amperage, let's see if I can show it to you again. So I've unhooked it, doing this with one hand. Alright, we hooked the yellow back up. We're pulling just under 2 amps. Now I'm taking the blue wire, which is the other ground rod, and I'm now putting it in the same spot as the yellow wire, which is some 2 ground rods together. And look what happens, the amperage went up. I take it off, I put it back, I take it off. So we've gained another, I don't know, a quarter of an amp to maybe a half of an amp, maybe a quarter of an amp, just from adding that second ground rod that's only in about 4 feet. So I don't think depth is as important, because they both seem to work the same. I thought current was dependent on depth at first, but it doesn't seem to be. Voltage definitely goes up about 6 to 8 volts, and amperage goes up at least a quarter of an amp to half an amp by putting both rods together. That would indicate that we have a much better ground and more electrons can be pumped from ground to drive this motor. Kilowatt meter still down here. I had to move it because don't unplug it. It's only been, and I unhooked it because I had to steal my extension cord back. But here we have, I don't know if this is upside down or sideways or the phone rotating or what, but here we go. 0 amps, 0 watts, 0 volt amps, 60 hertz, power factor 1, total accumulated kilowatt hours 0, for a total runtime of 21 minutes. So we're going to let it run and run and run, and I just pulled the wire off, and we'll let it run some more. So you notice this motor, it even shows sign of that induction motor pulling it down. So watch, we're at 0. When I first started up, it goes almost 3 amps, well 2.5, and then as the motor speeds up and balances, almost like it has a what do you call it, a centrifugal starter or whatever, it just speeds up and gets more efficient, and it pulls less amperage, and the voltage goes up as well. And our wire came off, so we weren't even using that second ground rod. It's still laying there. 76 volts, 85 with the ground rod, with both ground rods. No change in RPM, but slightly a little bit more amps. Unhooked, this thing will actually read 120 volts, and by arcing the terminals of this capacitor, my voltmeter jumps over 250 volts from the back EMF.